Welcome to today's lesson. We are going to be comparing ratios today. So, this is our session 3 for lesson 14. Previously, we did sessions 1 and 2 together combined, and in that lesson, we looked at our steps for comparing total parts to a total amount when looking at ratios. So now today we're looking at comparing ratios. So still talking about ratios, still finding equivalent ratios, using tables and different strategies and methods to help us find equivalent ratios. Okay, so let's take a look at the first problem. Charlotte and Pablo are each making purple paint by mixing blue paint and red paint. Charlotte uses 1 cup of red paint for every 2 cups of blue paint. Pablo uses 2 cups of red paint for every 3 cups of blue paint. Whose paint is a bluer shade of purple? So, we've got some information here, right? We've got some ratios. We've got Charlotte's ratio of red to blue, right? And then we've got Pablo's ratio of red to blue. And one of them uses more blue paint. So their purple turns out a little more blue than the other one. So let's take a look at your next couple of pages before we work this out together. All right. So there's 2 strategies that your curriculum suggests. Okay. You can use part-to-part ratios to compare the 2 ratios. So right now, Charlotte's ratio of red to blue was 1 to 2. Pablo's ratio of red to blue was 2 to 3. Now, they set up a table of equivalent ratios, and they just listed a whole list, right? All of these, top to bottom to top, they're equivalent ratios. 1 to 2 is equivalent to 2 to 4, which is equivalent to 3 to 6, 4 to 8, 5 to 10, 6 to 12, right? Same thing over here. They made a whole list of equivalent ratios. Now, notice something is the same about the ratios that they highlighted. So we have the original ratios, right? But then they're going with this one when looking to compare them. This one they left the same, but they changed Charlotte's ratio to make an equivalent one. So look at that and think to yourself, why did they do that? What was the purpose here? We're comparing ratios. When we compare things, something has to be the same about them, right? They're either both fractions or they're both decimals or something. They're both whole numbers. So we need to look at this and say, what's the same? We want to compare the blue. But in order to compare the blue, something has to be the same. So when we look at this, what I'm hoping we notice is that the amount of red is the same. So if we want to compare the blue, the red has to be the same. If we were wanting to compare the red, the blue would have to be the same, okay? So they made the red the same so that they could compare the blue, all right? And they did that by making a list of equivalent ratios for the ratio for each, all right? Let's take a look at the next strategy. You can use part to whole ratios to compare ratios. So again, original ratio, right? Original ratio. And this time, they're using this ratio for Pablo and this ratio for Charlotte. Again, when comparing, something has to be the same in order for you to compare. Hopefully we are noticing that the total cups is the same. So that is using a part, this is a part, right, to whole relationship. Part to whole. So if we want to compare the blue part, The whole has to be the same. All right. I would not recommend using the part to whole for this. If you want to, that's fine. It's a strategy. Okay. I like the part to part for this one. That's just me. So let's go back up to the original problem. Pablo and Charlotte. I would not make an entire list of ratios for this. Okay? Your curriculum suggests that, all right? It is a good strategy if you are struggling with your basic multiplication and division facts. Okay? It's a good strategy. But a lot of us know our basic multiplication facts. So instead, what I would do is I would set up my ratios. So I have Charlotte, and we are doing red to blue, right? Her ratio of red to blue is 1 to every 2, right? Then we have Pablo. Pablo again, red to blue. His cups of red are 2 for every 3 cups of blue paint, right? So now that we have this, and from what we just talked about, we said if we want to compare the blue, what has to be the same? We said the red, right? So if the red has to be the same, looking at these 1 and 2, I want to make those so that they are the same number. I could leave one of them alone and do something to the other. I would choose to leave Pablo's 2 alone, all right? Because for me, I know that I could easily make that 1 into a 2 by applying a rule here, times 2. Whatever I do to one side of my ratio, I have to do to the other if I want them to be equivalent, right? And that's what I'm finding. I'm finding an equivalent ratio where the red matches, okay? So 2 times 2 is 4. So now I'm comparing 2 to 3 to 2 to 4. So who has more blue in their purple paint? Charlotte, right? So we would write Charlotte's paint is a bluer shade of purple. So we are going to apply these steps, this method, to other problems. All right? And this skill of taking a table and finding equivalent ratios is going to be so important for you, especially as we move from ratios to rates. So just keep that in mind. This skill of being able to look at a table of equivalent ratios and find missing pieces to that is going to be so crucial when we move into rates. All right? All right, so we've been over those 2 pages. Okay, apply your thinking to new problems. So we're just going to go through some problems, all right? And it's going to be skills from the problem we just did, and we're going to build on that, all right? So number 1, for a science experiment, Jack adds 1 teaspoon of salt to 3 teaspoons of water. Mika adds 4 teaspoons of salt to 9 teaspoons of water. Whose water is saltier? No, you may be thinking, who cares? But it is a science experiment, so their science teacher cares. Jack adds 1 teaspoon of salt, so salt to water, right? So Jack has 1 teaspoon of salt for every 3 teaspoons of water. So we got Jack, right? We're comparing Jack's ratio to Mika's. Salt to water, right? All right. So Mika adds 4 teaspoons of salt for every 9 teaspoons of water. Now, we want to know whose water is saltier. So we want to see what the difference is between the salt. So if we're comparing the salt, then the water has to be the same. Just like in the problem before, we were comparing the blue, so the red needed to be the same. So I want to take a look at the water on each side. I have 9 and 3, or 3 and 9. You can think of it either way, right? I could make those the same. I would leave my 9 alone for Mika, and I would change this 3 to a 9 because I know that 3 times 3 is 9. Whatever I do to one side of my ratio, I've got to do that to the other side, right? 1 times 3 is 3. Now I'm comparing ratios that have the same amount of water so that then I can look and say, okay, which one has more salt? So, whose water is saltier? We see that Mika's water is saltier, right? 4 to 9 is larger than 3 to 9, right? So, Mika's water is saltier. All right, let's take a look at number 2. Tulsi and Gary are competing in a basketball free throw competition. Tulsi's ratio of free throws made to free throws missed is 3 to 5. Gary's ratio of free throws made to free throws missed is 15. Who has the better ratio for making free throws? All right. So lots of information in one little problem, right? So we have Tulsi. She's got a ratio of made to missed. Made to missed is 3 to 5, right? Gary has a ratio of made to missed. So I have to find my ratios for each, right? That's my first steps here. Each time I found each person's ratios, right? We're dealing with people in all these problems. Gary's free throws made to missed is 10 to 15. Who has the better ratio for making? So we want the making to be what we're comparing. So that means that missed has to be the same. So I've got 15 on one side and 5 on the other. I can make those the same, right? I want both to be 15. So I'm going to leave 10 to 15 alone. However, if I want my miss to be 15 over here, now I'm seeking an equivalent ratio for that. So looking at my past problems, I go, okay, well, what are we looking at with equivalent ratios? Well, there was a way to get from one number to the other. I had to figure out what that was, right? And then I had to do that to the other side. So that's my steps here. Same steps, different problem, right? So I want to say, how do I get from 5 to 15? Well, I multiply by 3, right? Same thing over here. If I do that over there, do it over here. 3 times 3 is 9. Now I can look and say, okay, my missed is the same. So now what's the difference in my made? Who is making more free throws? And we can see that Gary is making more free throws, right? All right, let's take a look at number 3. A store sells 2 types of cleaning solutions. Brand X has 4 milliliters of white vinegar for every 20 milliliters of water. Brand Y has 5 milliliters of white vinegar for every 30 milliliters of water. Which mixture has a higher concentration of vinegar? So we have a ratio, X. That's one brand, right? Vinegar to water, 4 to 20. And then we have brand Y. It has a ratio as well, right? Vinegar to water, and we have 5 to 30. And we want to compare concentration, so more, right? Vinegar. If we're wanting to compare vinegar, then water has to be the same. Oof. 20 and 30. I'm going to have to change both of these. So looking at this, I would look, since I'm dealing with a number with zeros, both of my numbers have zeros at the end, I can look for more of a basic fact here. 2 and 3. 2 times 3 is 6. I can make both of these 60. So if I do that, that means I need to figure out how I get from 30 to 60 because I want an equivalent ratio, right? So 30 to 60, that's times 2. If I do that to one side, I have to do it to the other. 5 times 2 is 10, right? So over here, I want my water to be the same, right? So this has got to be 60. 20 to 60, to get there, I multiply times 3. Then I do that to the other side. 4 times 3 is 12, right? So now I can see, now that my water is the same, I can see the difference between my vinegar. All right. So now that my water is the same and I can see the difference between my vinegar, which one has a higher concentration of vinegar? That means which one has more vinegar in it. All right. So we see that brand X has more vinegar. All right. Number 4. Here is a problem where they're taking what we've been doing, same steps, and they're adding some things to it. Okay. So number 4 says Tommy and Alethea plant a summer garden in their backyard. Alethea plants 3 rows of carrots for every 4 rows of pepper plants. All right, I'm going to stop right there and I'm going to check out Alethea here. All right. Carrots, rows of carrots to rows of peppers, right? 3 to 4. That's her. Got it. Tommy plants, so we got Tommy, 2 rows of carrots, 1 row of pepper. So still carrots, rows of carrots to peppers, right? 2 rows of carrots for every 1 row of pepper plants. Okay, got it. That's the ratio. If Athena plants 9 rows of carrots, there's some information. Athena now has 9 rows of carrots. Okay. And Tommy plants twice that amount. Twice of 9. 9 times 2 is 18. So Tommy is 18 rows of carrots. Who plants more rows of pepper plants? So now we need to find our equivalent ratios. This one is not about making something equal to compare. They're giving you an ending goal here based on your ratio relationship. So it's not the exact same steps, okay? So we want to find equivalent ratios here. So I have to figure out, well, how do I get from 3 to 9 times 3? So I have to do the same thing to the other side. 4 times 3 is 12, right? And then over here, I want to say, how do I get from 2 to 18 times 9? Have to do that to the other side. 1 times 9 is 9. So who has, at the end of this, who has more rows of pepper plants? So when they give you a rule like this, if this and that, then what? Then you've got to analyze that a little deeper, analyze a little further, okay? So we see that Athena has more rows of pepper plants, right? All right. Or Alethea, I'm sorry, call her different names. All right. Number 5. Summer campers John and Ryan are trying to earn their archery merit badges. All right, here's another one where they're going to change it up a little on you. Each boy has 30 arrows and must hit the center of the target more than 10 times. So that's an important thing to know. We'll need to know that for the end of our problem. Okay. John hits the center 1 time for every 3 arrows he shoots. Ratio right there, right? So we got John. He has a ratio of bullseye, that's hitting it in the middle, right, to arrows that he shot. So bullseye to arrow, 1 for every 3 arrows he shoots. Sounds pretty good, right? Ryan hits the center, bullseye, 2 for every 5 shots. All right. Which boy earns a merit badge for archery? Well, what's the rule? They each get 30. Ooh, each get 30. That's the same, right? So I want each boy to have 30 arrows. So now I'm finding equivalent ratios to see who meets that goal of more than 10 times with those 30 arrows. All right. So to find equivalent ratios, I have to say, okay, how did we get from 3 to 30 by multiplying or dividing? We're going to times 10. What is 1 times 10? 10. All right. Over here, same thing. 5 times 6 is going to get us to 30, right? 2 times 6 is 12. So, does Jack hit the target more than 10 times if he has 30 arrows? No, right? He's short. Ryan does, though, right? 12 times he will hit the bullseye with his 30 arrows. So, who is earning an archery merit badge today? Well, your boy Ryan is winning an archery merit badge. All right, let's take a look at number 6. Darius and Khadijah are learning to play chess. Darius's ratio of wins to losses. Boop, ratio. Darius wins to losses. 2 to 13. Khadijah, her ratio of wins to losses is 3 to 17. All right. Who has the better winning record? So we want to compare wins, which means losses have to be the same. Now, I don't like this problem because there's no easier way to do this, guys, that we have found in class. Most of my students, they start making a whole list of equivalent ratios and they're like, oh, just keep going and going and going. It's never getting anywhere. To make your losses the same, you're going to do 13 times 17. All right. 7 times 3 is 21. 1. Regroup your 2. 7 times 1 is 7, plus 2 more is 9. Put your 0 here because you're moving over to your tens place. 1 times 3 is 3. 1 times 1 is 1. We're going to add that together, right? So we have 1. 9 plus 3 is 12. 2, regroup your 1. 1 plus 1 is 2. So 221. 221 losses. That's what both of these need to have. 221. Well, to get from 17 to 221, multiply times 13. So I've got to figure out what 3 times 13 is. It's going to be 39. Over here, 13 to 221. Well, 17 times 13 is 221, which means if I flip it around, 13 times 17 is 221. I'm going to do 2 times 17. Well, what is 2 times 17? If you can't do that in your head, remember, you can always come over to the side and you can say, okay, what do we say? 17 times 2. 2 times 7 is 14. Carry the 1. 2 times 1 is 2 plus 1. 34, right? So Darius has 34 wins and Khadijah has 39 wins. So who has the better winning record? So Khadija has the better winning record, right? Okay, that brings us to your last problem. I want you to do this one on your own, okay? Arturo's food coloring uses the ratio 30 drops yellow to 27 drops blue. Ravi's food coloring uses the ratio 30 drops yellow to 24 drops blue. Linda says that Arturo's food coloring is yellower because 27 is greater than 24. Do you agree? Explain. Now, I will tell you this before you answer this on your own. Almost every student could tell me yes or no, but getting the full explanation was not something that everyone accomplished. Remember, when you are comparing ratios, something has to be the same. If you're wanting to compare the yellow, then the other part, which in this case is blue, needs to be the same. So if that blue is the same in your ratios, then yes, you're ready to compare your yellows. Just keep that in mind when you're explaining. All right. So answer that question on your own. If you have any questions for me about it, please reach out.